Okay. All right, let's jump right in. So hello, everyone. Thanks so much for joining. My name is Jack Naglieri. I'm the founder of Panther Labs. And just before we get going, I want to say I hope everyone's been staying safe with everything going on with COVID-19. I'm sure the transition's been really challenging to go fully remote for everybody. As you can see, I'm giving this webinar from my kitchen. So today I'll be discussing Panther 101, bootstrapping your cloud SIEM. So for the structure of this webinar, I'll go through a quick overview of Panther, what it is, why we built it. I'll talk a little bit about its design, its architecture. I'll step through use cases, how to use the core features, and then at the end, we'll do a small Q&A. So what are the challenges today? Security is a really hard thing to staff for. You know, as everyone who's a manager is aware, it's extremely difficult to find, talented analysts, talented security engineers, and specialized people who can, do detection in a more modern cloud world. The second issue is the tool sets at our disposal. Do we have the right things to be able to do this detection in the ways that, we want to? As we're seeing with the switch to cloud, the amount of data is really exploding. So we need, a more modern, automated way to go through all of our data. The last challenge that we often face is taking these, tools in our team and scaling this function out as the organization grows, as the demand for security becomes greater, and just sustaining the life of the team going forward. So for a little bit of a background on myself, I've been working in security for about 10 years. I started as a security analyst. I moved into doing security engineering at scale at companies like Yahoo and Airbnb. I was the core dev on StreamAlert. I also open sourced it in January 2017 at a conference called Enigma. And I ended up actually becoming a manager of that team, scaling the tool out even further, and then leaving to start Panther, which is essentially the next step in that journey. And since I started Panther, I've built a team. I've hired other security analysts, other security engineers with similar backgrounds. And we've taken all of this sort of culminated knowledge and built it into Panther. So it's really the combination of, how my team did it at Amazon and how we did it at Airbnb. So what we ended up coming up with is, an open source cloud native SIEM for modern security teams. And coming back to the word modern again, when I say modern, I'm referring to this idea of using automation for detection. And Panther can use this automation to do detection in our log data. So looking for threats, looking for suspicious activity, anything that's important to us as a security organization. The second thing it can do is improve your cloud security posture. So this is, analyzing your cloud security resources, your cloud resources, and making sure that they're configured in a way that, won't be vulnerable to really sort of basic low-hanging fruit. And more in depth, you can get more sophisticated as well with those detections. I'll talk about that in a moment. The final thing is powering your investigations and, doing postmortems, doing incident response, and answering all the questions that you need to during an incident. So the way Panther works is we first look at your cloud infrastructure. We map out all of the resources. We look at all of its attributes. We save it into our data warehouse. And then we also collect log data that's contextual to those resources. And the log data could come from, your laptops, it could come from VMs, it could come from network devices, clouds, really anything that can write to S3, we can take it and analyze it with Panther. And from the security engineer, security analyst perspective, they're interacting with the UI to build these detections, to browse the resources, to browse the alerts, do any of their triage work, and configure these alerts. So on the latter side, on the right side, we see alerts as our output. This can be Slack, PagerDuty, etc. Optionally, we can automatically remediate some broken cloud infrastructure as well. And I'll walk through that a little bit more later. So this is a high level overview. And why do we choose this and what's beneficial about it? So we built Panther fully serverless, and that means there's no running virtual machine. It's all built on top of AWS Lambda, DynamoDB, S3, SQS, the cloud native services that Amazon sort of manages for you. And the benefit of that is that we don't have to worry about scaling anything. There's obviously best practices that you have to take into consideration when building an architecture like this, but we've been doing this for a very long time, as I mentioned, with Streamalert and how my team did it at Amazon. So we're fairly familiar with, the sharp edges and how to get around them. The second benefit of this architecture is that it's self-hosted, so you don't have to really worry about the data ever leaving your premise. When I say premise, I'm referring to your cloud. You can spin up a specialized account just for Panther, deploy it in there, and do all your analysis within your control. And then the other thing we really love about this architecture is that it's super flexible. So we do all of our detection logic in Python, and this means that you can write analysis on your cloud infrastructure in Python, and I'll show how to do that in a moment. And then you can analyze your log data with Python as well. And the benefit with this is that you can use all of Python's built-in libraries. You can use third-party libraries. You can even use your own internal libraries as well if you have any. And you can just get really creative with how you do your detection. So you're not really bound by a domain-specific language. The final thing is cost. So serverless is pay by usage, and it's extremely cost effective at scale. And the way that we designed it, we try to avoid the use of any sort of expensive service as well. And this scales very nicely as we feed more and more data into the platform. So when we look at our use cases, generally what we see people using Panther for are taking host-based IDS data or host-based instrumentation and detecting compromise. So generally, this is looking at output of tools like OSSec, OSQuery, syslog, auditd, anything on the host level. And sometimes these tools actually generate alerts in themselves, and we can use Panther to further filter the alerts, to maybe look for certain patterns in the alerts that we really care about as a team, and sort of filter out some more of the noise. The second use case is quickly searching our indicators. So we do a ton of work and pre-processing on the data before it's really written out to our data store. And this work is to extract out common indicators like IP addresses, domain names, really anything else. And that's very useful because what we can do with Panther is we can take an IP address and we can search for an occurrence of that IP in all of our logs, which allows you to do correlation in an effective, scalable way. On the infrastructure side, you can use Panther for analyzing all of your AWS IAM roles and looking for things that are overly permissive. And that's a more basic use case, but as I mentioned, we have access to third-party libraries. And one that's really interesting for this use case is called Policy Universe, which I believe is a Netflix tool. And you can load Policy Universe in with Panther, and you can start to inspect your policies on an even deeper level. So you can get more sophisticated. Finally, network traffic is a really common use case because it generally tends to be super high volume and very expensive to process in a traditional SIEM. So this could be taking in VPC flow data, it could be S3 access logs, Circata, Zeek, any other network IDS or sensor is a great use case for Panther. So I'm going to give a scenario and sort of walk through how a team would use Panther from start to finish, and we'll walk through a sample scenario. So let's imagine for a moment that you have a fleet of virtual machines and some SSH credentials are phished. Let's also say that there's no two-factor authentication for SSHing in, and an attacker gets in and starts enumerating around, seeing what access they have. What can we do as a security team using Panther to detect, investigate, and remediate this? So some terms I want to lay out before I get into the scenario. So when I say a resource, I'm referring to a cloud component like a virtual machine or a user or an S3 bucket, something like that. Policies are functions representing the desired state of those resources. And then on the log analysis side, a rule is a detection function for looking at suspicious activity on events, which are this normalized log data that's come in from either your host, network, cloud sensors, anything. And then finally, alerts are those things that we get at 3 in the morning when someone hacks into all our stuff. So moving on. The incident response lifecycle, if you've been working in incident response for a while, you've probably seen this a lot. NIST has the famous 4 phases, but really where we start is, we want to build some detections. We want to detect our activity, and then we want to start to gather our indicators, our evidence, do some queries on all of our log data, and then we want to contain the incident, do a postmortem, and then we want to update our detections again. And then this cycle sort of continues as time goes on, as the team gets more mature, adds more data, etc. So in Panther, the way this looks like is, we first craft our detections. So this screenshot just shows our list rules page. And in this page, we can sort of filter out all the existing detection rules that we have today, either by its type, its severity, some customized tags, etc. And then, either in the UI or on the command line, you can, using Python, craft these detections. So the first one that we're going to look at for this scenario is somebody logging into my instances from a non-office network. And in this example, we're using just a sample /24, but this can be really effective if you have specific egress points for logging into your systems, which most companies do, either with a VPN or with specific office networks. So this rule function takes in an event, which is our parsed log from OS query in this case. And then we're checking the host column, making sure it's within the network. As you can see, we're using the Python IP address library, which is also sort of just leads back to the fact that, Python is really powerful and you can get really creative. The next thing we want to look for and we want to monitor for more generally is a volume of access denieds in our Amazon account. So using CloudTrail, you can monitor this. And this can generally indicate either misconfigured automation that's happening, or it could be someone who got access to access secret keys and now they're trying to enumerate around and see what they can do. So the next step is, now that we have our detections, let's actually detect and let's triage. So this is the screenshot from our hacker. They log into our network from a non-approved IP address, as we can see here. And then what they start doing is saying, okay, do we have the AWS CLI installed? Okay, we have it installed. What can we do? Can we get users? Can we list? Can we create things? And we see a bunch of access denied here. Some of these might succeed, some of them might fail. Let's take a look. So the detections that I set up, I have it configured to send to Slack. So in our Slack channel, obviously you wouldn't want to use Slack for a high priority one. In a real scenario, you would use PagerDuty or something that actually would call your on-call. But for the purpose of this demo, let's just say it writes to Slack. So in this view, we see, okay, we get an alert from someone logging in from an outside network, and we see a second alert right under that, which is monitoring unauthorized API calls. So when we click through to our UI, we can get more information on those events. And we can also configure with our rules certain logic to merge the events based off of either time, the user creating, the user causing the activity, the host. You can really control that however you want. But from these triggered events, we can start to gather some of these indicators, such as, what's the IP address that this attacker logged in from? What's the compromised user, and what is the instance that they connected to? So taking this information, we can sort of pivot around to SQL, and then we can write a query that essentially gives us what the instance ID is for the IP address. So this query is essentially looking at our VPC flow logs. And when you're writing queries, and this is in Athena, you would look at the Panther logs database, which is all of the log data that you send into Panther. And then the flow log table is all the AWS VPC flow logs. And we're filtering based off the time frame of this alert. And then what we get is an instance ID that we can take and we can get even more information on. So as I mentioned in the beginning, Panther does baseline scans of your entire AWS account or multiple accounts. You can really onboard as many as you'd want. And what you get is a way to view all the attributes of these resources. And then that allows us to understand certain important state information during an incident. So if we look down, and I apologize if this is hard to see, but now that we know the instance ID, we can pivot around into the resource attributes. And now we have the IP address of the host, we have the fully qualified domain name of the host, and just other things that we can use to further pivot and get even more information. So now that we start to, now that we have the instance IP address, let's see what else happened in this time frame for this instance. So we take the public IP, we see, okay, there's some logs in CloudTrail. If this IP showed across any of the log types, we would see them listed here, but this is querying a different database. So we have an idea called a view. I guess it's a more sort of generic database concept, but we have a table or a database called Panther Views. And this allows you to really take these indicators and search across all of your log data and then look at that log data further. So this is telling us, across all of your log data, I found AWS CloudTrail as a related log type for this IP. So we can pivot again, and now we can see, okay, let's look at the CloudTrail for that IP address for this date and time. And now we start to see the access denied calls, more context, and we can just really crawl through this data and get a better sense of everything that happened within this time frame. So, we can continue our investigation. We can sort of determine what the blast is of this breach. We can then remediate with Panther itself if you wanted to. Oh, sorry about that. So Panther has automatic remediation. I mentioned this also in the beginning. So the way this could work is, we have policies that are set up looking at your network ACLs, looking at your security groups, et cetera. And we have remediations that, when you click this button, what will happen is a role will get assumed, it'll make an API call, and it'll fix whatever this resource is. And this is really helpful for containment. Less so as a scalable way of doing configuration management. It's more so just for, in the event of an incident, you need to remediate something really quickly. This is one way you can do that. So you can click remediate, it'll go do that, and then effectively that would cut off the access. And then, we can shut the instance down, we can do forensics and just more in-depth investigations. So in terms of supported input and output, Panther has a lot of different support for different resource types within Amazon. We're just limited to Amazon today. We are thinking of a multi-cloud strategy, but at the moment, we just focus on Amazon very deeply. So, this is looking at our S3 buckets, at messaging, queues, topics, et cetera. And this isn't a full list. Our docs have all the supported resources, but this just gives a basic idea. In terms of log support, we can take in data from Zeek, Circata. Very soon, we'll have the Palo Alto Network firewall support, host-based IDS, like I mentioned, like OS Query, OSSec. We can do syslog. We can do essentially, I'm pretty sure we support all Amazon logs that are relevant for security, at least. And then Go Audit, that's what the Slack logo is for. And then taking in data from log aggregation frameworks like Fluentd or Logstash, which have a ton of support for writing to S3. And then for sending our alerts out, we can create tickets on GitHub. We can send messages in Slack. We can loop into really any workflow that you would have with your team. If something's not listed on any of these slides, just feel free to reach out to us, make an issue on GitHub. And Great. So what I'll do now is I'll just sort of click through around the UI, show a little bit of what I just talked about, and then I'll save some time at the end for questions. Let me share my screen. Great. So when you first open Panther, you're greeted with a homepage, and this just provides a guide on how to really get started. So you want to invite your team, you want to set up monitoring for scans, onboarding log sources. We've done a lot of this already in this account. So let me just show, for example, some resources. So if you click through, we have two main menus on the left. One focuses on cloud security, which is infrastructure health, checking our policies, and looking at certain resources that we would want to triage and fix first. So this gives sort of a rank of top filling policies and top filling resources. Clicking through policies, we can search and filter. So let's look at security groups, for example. So we can see this policy is looking for restricting inbound traffic. We can see all of the associated resources with it. So if we look at the failing ones, we can click through and we can look at the security group specifically that's failing. And then now we get all the resource attributes. And then we can also see the associated policies again. So we have this bidirectional view with resources policies, and it's the same with logs and with alerts and rules. In sources, we can see our configurations here. We can add new accounts, step through. We provide CloudFormation templates for connecting all the accounts together. Panther itself is also fully deployed with CloudFormation. And infrastructure as code has a ton of benefits, obviously, with reliability, repeatability, et cetera. So if we click through with rules, as I showed before, it's the same sort of filters with policies. We can look at, do we have CloudTrail rules loaded up? And do we have high severity CloudTrail rules, for example? So let me actually take an OS query one as an example. Clear this. Great, so here's our demo rule, and then we can see there's some generated alerts from that. Let me actually use this one as an example. So yeah. So as I said before, you can click through and you can see, okay, so we had a login from outside the corporate environment. We get all the context from OS query. We can see the user, we can see the time, and then these fields, these P underscore fields, are the common ones that we extract out. And then these are also searchable in Athena as well. The other thing that's really great about how we do our alerting is that it merges based off of certain dedupe strings. So in this case, we're looking at the username and the host name, and then we can see all the activity related within that time frame. So in this case, this rule was looking for AWS commands on the command line, and we're grouping it by host and user. So if we look at command under here, columns command, we can see all the different commands that they typed. And this is all searchable in SQL as well. So if you have a very high amount of events that you need to go through and run statistics on, you can do that with SQL. And then I think that's essentially most of it. Yeah. So we can search our rules, we can search through our alerts, and we can get a sense of the high prior alerts, what's an overview, I guess, essentially at a higher level here. And then we can see our log sources as well. This is using S3 primarily, as I mentioned. So if you want to add new buckets, we would go through and create IAM rules that Panther can assume to pull the data. So just because we're coming up on time, I want to quickly say, so what I stepped through today is our community version. And we have multiple tiers available. So we have our open source community, which has all of the core features of Panther that I just walked through. And we also have an enterprise level of Panther as well that has additional detections built in. We have RBAC, some additional enterprise-y features like reporting, analytics, audit logging, and things for more bigger organizations, for organizations that want to share Panther out with multiple teams. And we have some additional exciting, really exciting features coming as well for enterprise. But if you want to download and play with Panther today, we are open source, github.com/pantherlabs/Panther, and you can go download and install today. Our docs have a ton of information on how to do everything that I just walked through. So yeah, we'd love to save time right now for Q&A if anybody has questions. Okay. So the first question is, when querying data, can you explain differences of Python and SQL? When would you use either one? Okay, that's a great question. So we use Python for doing real-time detection. And this is on data ingest. What happens is the logs are parsed, they're normalized, we do the common fields, and then we do our analysis in Python, and then we send out our alerts. And then SQL is for the latter part of that. Where you're doing investigations, you need to query over all of your data. You need to do joins across your data. You want to look at things that are more macro level. Python is used more for very tactical behavioral detections. Cool, great. And then second question, can we use CloudWatch logs as an input? We can easily support it. I believe CloudWatch logs can write to Firehose, which can write to S3. So that could be one workaround. If that doesn't end up working for you, we can, happy to chat on a GitHub ticket about it. Just feel free to create an issue. Share the slides. Yeah, I think that should be fine. I think we'll have this whole thing's recorded anyway, and it'll be on YouTube after. I'll see what we can do about sharing the slides out as well. These are great questions. Does anyone have anything else? I also have some other members of my team in the call too. So if anyone wants to ask about our historical data or just the workflows for rules, I have Nick, he's our security engineer. Russ, are you on as well? Yeah, he's on. So how long does a SQL query usually take to complete? So this really depends on how you're querying. Generally, it's a couple of seconds. We partition all of our data pretty well, and I think we get as granular as the hour. And Russ, feel free to just jump in on the chat. But it's fairly quick. In enterprise, we actually have a upgrade to use Parquet data, which at a certain scale is much more performant, depending on the query you're typing. But we partition everything, and that allows the queries to run pretty quickly. This is a great question. So can you access Panther programmatically? Do you have an API? So this is something that we're actively working on at the moment. In terms of the current support for programmatic access, you can upload your detections programmatically with our Panther Analysis tool that Nick has developed. So the way that works is, using, I can actually share my screen again. I'll walk through that. Okay, so in this repo Panther Analysis tool, this sort of lays out all the things we can do with testing our detections locally, but there's an upload command, and this allows you to take a zip file, upload it to Panther, and update all of your rules and policies. And this can also be done in CI as well, if you have the proper permissions to Lambda. Happy to chat more offline about that. But if we also look really quickly at our Panther Analysis repo, so this is also an open source repo. You guys can check this out today. But we have all of our built-in detections here. And when you install Panther, we actually pre-install it with these rules and policies. So for example, if we look at some of the CloudTrail sample rules. So this one's looking at, if a user updates their credentials. So we can see we define it as a Python function, our rule, our dedupe logic, and what the alert title is going to be. And then we have a spec file that lays out all the attributes to this rule. So it's the log type, the tags. You can add unit tests as well, which is really helpful. So we can essentially ensure that our rule will always fire when we get this proper data. It can be pretty challenging to really gauge the effectiveness of a rule without a feature like this. And we have a ton of data, we have a ton of info in our docs on how this all works. Okay, let me scroll back up. What infra costs do customers usually see per ingest volume? So this is a great question. A lot of the cost is actually around S3. Actually, probably like 95% of the cost is storage, and compute is so minimal. I have cost estimations in our docs, and if I pull up our docs really fast, so I put this under help cost, and I think I use a terabyte a day as the sample. So for doing a terabyte of data a day, which is 30 a month roughly, we see the AWS cost as around 3K, and this really depends on primarily your storage retention. So this is for retaining a year of data. It would cost about 3K on Amazon, and this could obviously be optimized for your storage classes, and this is also further optimized by using Parquet, which is available for enterprise. Remediation button has predefined. All right, so this other question, the remediation button has predefined playbooks running in the background. If yes, is it possible to be modified according to our needs? Yeah, all right, so the way automatic remediation works, it's very similar to a detection rule. It's a Python function that gets invoked when you click that remediate button. And another option is you can actually set up an alert output to be SNS or SQS, in which case you can invoke whatever pipeline you wanted. And this kind of plays into the next question about SOAR. So I think for SOAR, our strategy is more so integrate with the platforms versus, to be the platform at the moment. We want to really focus on the core problem, which is really taking all this security data, normalizing it, analyzing it, and storing it, and forwarding it on to other tools that do more complicated analysis, like maybe binary analysis, doing advanced orchestration, like with a tool like Demisto or things like that. So I hope that answers both of your questions. Does anybody did I miss anybody? I think that was it. Does anyone have any other questions? I think we're coming up on time. Yeah, great. So yeah, you guys can definitely go or can go check out our open source. You can try it out. We also have a public Slack channel. If you go to, Will is pasting everything in I'm saying. Great. If you go to our sign up page for Slack, the whole team is on there. You can pick our brains some more there. But otherwise, thank you so much for your time. Hope this was informative and helpful for you, and really looking forward to working with everyone going forward. So thank you.